Hi everyone, I'm Ritvik, a passionate data specialist or data scientist, whatever you prefer to call me. And many of you know me from my posts on LinkedIn. I'm soon coming up with a series of short videos on various interesting topics related to data science, statistical learning, statistics, and machine learning. So, machine learning or AI, as many call it, is truly fascinating. So the way I like to think of it is it's a science of prediction. So at its core, machine learning is all about making forecasting, whether it's predicting the weather or estimating the likelihood of heart disease in a patient, or even it could be identifying which category an image belongs to. So these days, image classifiers are becoming very popular in certain business segments like e-commerce. So typically you start with some labeled images, the images which you already know. And based on these images here treated as data, so you train a model. And then when you have an unknown image, or I would rather say out of the box image, you can actually predict using the algorithm or the model to which class or category it belongs to. So it's a fantastic tool. And the most popular algorithm used for image classification is what we call as convolutional neural network. So there are various branches of machine learning, but my focus is mainly on supervised and uh, unsupervised machine learning techniques. And recently, I have also started teaching into large language models, which comes under natural language processing, which is again an upcoming field in machine learning. So this particular video is made for metallurgists and material science specialists or material science engineers who actually lack the understanding of the potentials of machine learning. So this is the community which I come from. So I've noticed that many in our fields have not really grasped the concepts of machine learning. And trust me, it can do wonders. So the foundation of every machine learning algorithm is data. And that is why I say data is the fuel or the feed for any machine learning algorithm. So I'll quickly take you through an example of a data frame where we can apply supervised machine learning algorithm where you have historical labeled data. So labeled data here refers to a data frame of observations with many inputs and correspondingly one or more output, which could be binary or it can have some numerical values. So this data frame has been downloaded from website. So this has entries for students' academic records right from high school till university. And it has also the information on the age and gender of the students and if they have pursued MBA. So the other point to note here is that to this data, some feature has been labeled, like whether the candidate has been placed or what has been the joining salary. So all these informations are combined in the data frame. So using this data, you can train a model. So it could be a linear regression or logistic regression, or could be decision tree. So there are various other supervised machine learning algorithm. So by training here, what we mean is that your model tries to capture a pattern, that it tries to learn the relationship between the inputs and the corresponding output. So here all my input data are shown in green, while the output is what is represented in brown. So now that you have an unknown data, or what I call as an out-of-the-box observation, which has all the inputs, but there is no output known for the data, you can apply the model on this unseen data, so it will be able to predict the output. And that is the basis of all the supervised machine learning algorithms. So today I'm here not to teach you how these machine learning algorithms work, but I'll be introducing you to a very interesting website. It's called Teachable Machine, and I have been a user of this platform for quite some time. This has an inbuilt image classifier that uses convolutional neural network that runs in the background. So I have actually collected a range of fractographic images for ductile fracture and brittle fracture, some of which I can show you right here. So these are images from ductile fracture. So I have tried to capture all the possible morphologies of ductile and brittle. And then I have for brittle fractures this nice river-like patterns, and you have some of these having this flat facets. So this way, I have identified those which are ductile and those which are brittle. And I'm now going to upload all these images. So these images, what I call as labeled image. Here I go. So I'm going to take all the brittle images and call this class as my brittle. Then I also take images from ductile. And I call this label as ductile. So my training data is created. I've classified these images as brittle and ductile. The next step is I have to train the model with the existing images that I have in hand. So let's wait for the training. It should not take more than a few seconds. So once this is done, I now switch it to file. And what I'm going to do now is choose any random test image. Say, I want to see if this is, so this is an image of brittle fracture. So this is something which was not included in my training data. And now you can see I have uploaded this. So this particular image is what I call as an out of the sample or out of the training data image. But it has been able to accurately identify it as a brittle fractography image. Likewise, I can change it to a ductile one. And let me see. So yes, it has correctly identified as ductile. You can see that. And what about if I do with a mixed fracture? Let's see how it responds. Hey, so this is a mixed fracture which has both ductile and certain signatures of brittle fracture. So it shows me around 82% of, let me zoom the screen. Here I go. So this has identified as a mixed fracture with 82% brittle, ductile, and remaining 20% as brittle. So this way you can employ this machine learning algorithm to identify or to classify any unknown image. It could be a microstructural image, it could be a fractographic image. So this is a beautiful tool, and I would encourage people in the material science or the metallurgy community to come forward to use these tools. So let us be technologically updated. So that was all I wanted to share with all of you. Thank you very much.